So we're going to talk about how partial pressures and mole fractions kind of go together. And then when we come into class 2, we'll talk more about actually calculating mole fractions using this formula right here, which is the moles of a component. So again, you're usually given grams or some kind of indication like that, or straight up moles, and you divide by the total moles in that container, okay, or in that gaseous mixture, whatever it is, okay. So again, it's just adding in. It's actually very simple. It is what it sounds like. It's mole fraction. So when you take a fraction, it is a percent, but without putting in percent form. So it's a decimal form of a percent. So if you take the amount that you have, and again, it has to be a mole, that's why it's called mole fraction. It's labeling and telling you that. Over the total moles, you're going to get the fraction of each gas in that mixture. So you can do that. And you can pay attention now for questions about a particular gas, or maybe I'll ask you for the each gas, like I'm going to ask you in this one. Now, this one has just a little twist on it. It looks huge, and I like to show you problems like this where it's like super wordy. ACT is known for doing this in their science section because they're just testing you on your persistence. So they're saying, hey, are you college ready? Are you going to not give up? Are you going to try? Are you going to persist through things, even though they may seem really hard at that time? Or are you going to keep going, okay, not give up? So this is what they do. So they give you like a big old wordy thing and lots of extra information maybe at times. And you're like, what do I use? So here we go. For data gathered from Voyager 1, scientists have estimated the composition of the atmosphere of Titan, Saturn's largest moon. So we're learning a little extra stuff there. The total pressure on the surface of Titan is 1,220 torr. So we got a total. Okay, this is pressure total. All right, so a little labeling does help occasionally. The atmosphere consists of 82 mole percent. Now, here's the difference between having a mole fraction and a mole percent is they've already done the work, okay? They've already put it in fraction. So this would be 0.82, but we're calling it a percent, okay? And we can apply it like this. So I want to show you how you apply it because I think you guys are able to do the fraction part. But the percent actually is really, it's actually the easiest part of it, okay? And this, again, 12% mole percent of argon, and it's already mole percent, again, mole percent, of the methane. So it says to calculate the pressure, calculate partial pressures, the part of the pressure that belongs to them. So again, it's just part. Partial pressure sounds complicated, but it just means what part of is the pressure of that particular gas of all those gases in Titan's atmosphere. So we're looking for nitrogen's partial pressure, we're looking for argon's partial pressure, and methane's partial pressure. Okay. So what do? Well, we know the total, all right? So if you want to know the pressure of nitrogen, let's just think about this for a second, make this not hard. The total is 1220, but nitrogen is 82% of that. Wow, I don't think this is a hard problem because this is just math. It's 82% of the 1220. We know, hopefully, just even like taking tax, if you had to pay $1,220 for something and it was 82% tax, you wouldn't be too happy. But what would you do to solve for that? You would take it times 0.82, which is actually the mole fraction, okay? So this is the interesting part of it. I hope you see how it all relates. And so we would just multiply 1220 times 0.82, and we'd get 1,000, 0.4 torr. Okay, so that's question number, here I can label it very carefully here, pressure of nitrogen, so I know. All right, we're going to do the same thing. For argon, it's just going to be, argon's a lowercase r, whoopsie doodle, that's terrible. I would cross that off and write it correctly, little r, because it does matter a lot in chemistry. We're still dealing with that same total, but this time argon is 12%, so 0.12 is that fraction of that, not mole fraction. And so 1220 times 12% is going to be 146.4 torr. And that is, again, the pressure of argon. We're just rolling right along. And, of course, we just do one more, a pressure of methane. And that is, again, the same total because they're all in the same atmosphere. They're all just mixing. And that percent is 6%, which is 0.06 as a fraction, right? So we're only going 6%. That's more like what tax would be, right? And so we'd multiply to get that. 73.2 torr is the pressure of the methane. And so we have all three of our answers. Hey, you can check your work here, right? If you add up all three of these pressures, it'll give you 1220, or you did something wrong. All right? So that is how we do this. hopefully that's an easy way to show you that. I'm going to go ahead and stop on mole fraction right now because we'll go to kinetics and I'll put it in a second video.